In this video, we will derive the equivalent radian measure of special angles that are in degree measures. An arc of a circle whose length is equal to the radius of a circle has an angle measure of 1 radian. If this were our unit circle, a unit circle has a radius 1, so the length of C of line segment CB and line segment CA, their measure is 1. And so if this arc has a measure also of 1, then we say that the measure of this angle is equal to 1 radian. Okay, so this is our notation for the measure of an arc with endpoints BA. And 1 radian, in fact, is approximately equal to 57.29 degrees. Let us derive the radian measure for 30 degrees. So this is 30 degrees. So we are looking for T. T is the length of that arc with endpoints D and E. The length of that arc is what we call the radian measure of our angle whose degree measure is 30 degrees. Okay, so how do we do that? Well, we shall take advantage of the properties of proportionality. So the degree measure is directly proportional to the radian measure. So with that in mind, T, the ratio of T, or the length of that arc DE, to pi. Okay, what is this? T over pi. It's this. It's the ratio of this arc to the length of half of the circumference of our circle. That ratio is equal to the ratio of 30 degrees to 180 degrees. So this is 30 degrees. And the straight angle is this one. 180 degrees. So these two ratios are equal. Let us solve for T. So T is equal to pi over 6 radians. So the equivalent radian measure of a 30-degree angle is pi over 6. How about 45 degrees? This is 45 degrees, and we are looking for the length of that arc. The arc whose endpoints are D and E. So let us set up our equation. The ratio of T over pi is equal to 45 degrees over 180 degrees. Solve for T. So the equivalent radian measure of a 45-degree angle is pi over 4. How about 60 degrees? This is 60 degrees. The equivalent radian measure for this angle is the length of that arc with endpoints DE. So again, let us set up our equation. The ratio of T, the length of that arc, we don't know what it is, to pi. Pi is the length of 1/2 of the circumference of your unit circle, is equal to the ratio of 60 degrees to 180 degrees. Let us solve for T. So T is equal to pi over 3. An angle whose degree measure is 60 degrees has a radian measure of pi over 3 radians. So these are our special angles in degree measure And these are their equivalent measures in radians. 0 degrees is to 0 radians. 30 degrees is to pi over 6. 45 degrees is to pi over 4. 60 degrees is to pi over 3. 90 degrees is to pi over 2. 180 is to pi. 270 is to 3 pi over 2. And 360 degrees is to 2 pi. Again, you can derive again this radian measure with the help of your unit circle. So you may want to finish this picture. This picture is showing to you the special angles and their equivalent measures in radian measure. So why don't you finish this picture? Show the angles in degree measure and their corresponding measure in radians. So you can show it for 120 degrees, 150 degrees, so on and so forth until you get to 360 degrees.